Hi, this is Navin. Today we are going to solve the given problem. The problem is a capacitor 4 microfarad charged to 50 volt is connected to another capacitor of 2 microfarad charged to 100 volt with plates of like charges connected together. The total energy before and after connection in multiples of 10 to the power of minus 2 joules each. From this, what is the given data? Given that, first you have to write the data. Given that, what is the first capacitor? C1 is equal to, let us assume the first capacitor will be C1. C1 is equal to 4 microfarads and V1 is equal to 50 volts. We have to find out the energy stored in the capacitor in 4 microfarads and 2 microfarads separately. After that, you have to find out the total energy of the two capacitors. After that, we have to find out if the two capacitors are connected in parallel. How we can say parallel means they here mentioned of like charges are connected. Like charges are connected together means there is a parallel connection. We have to find out the energy stored in parallel connection. First, I have to find out the energy stored in first capacitor. First capacitor C1 is equal to 4 microfarads, V1 is equal to 50 volts. What is the energy formula? Energy stored in capacitor formula, U is equal to of CV square. Here, U is equal to of C1 V1 square. Therefore, U is equal to of into, what is the C1 here? 4 into 10 to the power of minus 6 into, what is the V1? 50 whole square. What I got? 2 into 10 to the power of minus 6. 50 whole square means I'll write 25 into 10 square. From this I got 50 into 10 to the power of minus 6 into 10 to the power of 2. I got 10 to the power of minus 4. It is also written as 0.005 joules. The energy stored in first capacitor, I got 0.005 joules. In same way, we have to find out energy stored in second capacitor. What is the second capacitor here? C2 is equal to 2 microfarads and what is the voltage? V2 is equal to 100 volts. What is the energy stored in U2 is equal to of C2 V2 square. Therefore, of into, what is the C2? 2 into 10 to the power of minus 6 multiplied by 100 whole square. What I got? 2 cancel to each other. I got 100 whole square means I'll write 10 to the power of 4 into 10 to the power of minus 6. We get 10 to the power of minus 2. It is also written as 0.01 joules. Now I got the energy stored in first capacitor 0.005 joules. Energy stored in second capacitor 0.01 joules. What is the total energy? Total energy before connection. Because they are asking the total energy before and after connection. The total energy before connection, U is equal to U1 plus U2, 0.005 plus 0.01. What I got? 0.015 joules. That is also written as 1.5 into 10 to the power of minus 2 joules. If the capacitors are not connected in parallel, before connecting in parallel, the total energy becomes 1.5 into 10 to the power of minus 2 joules. After that, if the two capacitors are connected in parallel, we have to find out energy. What is the energy formula? Same, U is equal to of CV square. This is the formula, energy stored in capacitor. But here, see, we can calculate the parallel by using the capacitance formula. You can find out the capacitance here while it is in parallel. And what about V? Let us assume the common potential V connected here. Let us assume this is the voltage V for the two capacitors. Now how to find out the V? Let us assume this is C1, C2, it is V. How to find out V? According to the law of conservation of charge, we already know that Q initial is equal to Q final. Q initial means before that, what is the Q? Already we know that Q is equal to CV. Before that, Q initial means shall write C1, V1, C2, V2 for the two capacitors, and the Q final means I will direct total capacitance, nothing but resultant capacitance of these two capacitors after connecting the parallel, and it will be equal to C and the voltage will be V. How to find out what the C1 4 into what is the V 50 plus what is the C2 2 into what is the V2 100, that is equal to what is the total C. If the capacitors are connected in series, what is the formula? 1 by C1 plus 1 by C2. If the capacitors are connected in parallel, what is the formula? C1 plus C2. You can directly add the capacitors. I got 4 plus 2, 6V. From this, 4 into 50, I got 200 here. Here also 200 is equal to 6V. From this, V is equal to 400 by 6. I got 200 by 3. Now, how to find out the energy here? How to find out then the same formula? U is equal to of CV square. This energy after connection. Now, off into what is the C value? C value 6 microfarads. 6 into 10 to the power of minus 6. What is the V here? 200 by 3 whole square. What I got? 2. It will be cancelled. 3 into 10 to the power of minus 6 multiplied by, shall I write 4 into 10 to the power of 4 by 3. Here 3 cancel. I got 4 into 10 to the power of 4 means here it will becomes 9. One more 3 there, and I got 4 by 3 into 10 to the power of minus 6 into 10 to the power of 4. I got 10 to the power of minus 2. 4 by 3 means what is the value? 1.33 into 10 to the power of minus 2 joules. Now, if the capacitors connected in parallel, after connection, the energy stored in the resultant capacitance will be 1.33 into 10 to the power of minus 2 joules. Before connection, the energy stored in the capacitors will be 1.5 into 10 to the power of minus 2 joules. And for single capacitor, the energy stored 0.005 joules for first capacitor, 4 microfarads. For second capacitor, the energy stored in second capacitor 1.5 into 10 to the power of minus 2 joules for second capacitor. It is clear? They are given the two capacitors along with their voltages, and they are asking if they are connected in parallel, what is the total energy stored in the resultant capacitor, and they are asking before connection how much energy stored by the capacitors, and after connection how much energy stored by the capacitor. We simply find out first. Individually you can find out the energies. After that you can add the two energies. We got 1.5 10 to the power of minus 2 joules before connection. After connection we are using this one. According to conservation law of charge, Q initial is equal to Q final. We know that Q is equal to CV. From this I can write for the first capacitor Q is equal to Q1 is equal to C1 V1. Second capacitor, let us assume Q2 is equal to C2 V2 is equal to CV. This is the total final charge. If you calculate that, you got 1.33 into 10 to the power of minus 2 joules. This is the answer. It is clear? Thank you.